Well, good morning, everyone. Welcome to the webinar today. My name is Carrie Berger, and I'm the coordinator for the Northwest Fire Science Consortium. For those of you not familiar with the consortium, we are one of 15 fire science exchange networks that are funded by the Joint Fire Science Program. Part of our mission is to disseminate regionally relevant information to our stakeholders in Oregon and Washington. We try to do this by offering a diversity of opportunities for people to participate in, and hosting webinars is just one way we accomplish that. To learn more about the consortium or to sign up for our monthly newsletter, visit our webpage at northwestfirescience.org. So to avoid any noise interference, I have muted your audio, so if you have a question, please type it into the chat box. Also, I will be recording the webinar and will archive it on our website and YouTube channel. You can find both those web addresses in the chat window. So I had the pleasure of meeting Susan O'Neill last week in Boise at the Smoke Management Workshop. Susan is an air quality scientist with the USDA Forest Service Pacific Northwest Research Station Air Fire Team, and she has a PhD from the Laboratory for Atmospheric Research at Washington State University. She began her Forest Service career in 2002, leading the development effort for the first version of the BlueSky Smoke modeling framework. She then continued on to the USDA Natural Resources Conservation Service as part of their air quality and atmospheric change team, and in 2012 rejoined the Air Fire team. Her research interests include fire emission calculation and modeling smoke dispersion, transport, and chemical transformation. So Susan, I'm going to turn it over to you, and whenever you're ready, go ahead.
Okay, great. Thanks, Carrie. And thank you to you and Cindy for inviting me to do this webinar. So good morning, everyone, or good afternoon if you're in the East Coast. So I'm Susan O'Neill, and I'm going to talk about smoke tools and information, excuse me, for prescribed fire and wildfire. And so I wanted to give an overview to give an idea of where I'm going with this talk. So I'm going to talk about several different components. First, I'm going to cover smoke forecasting systems. So there's actually several out there, and the one that I've been working on and developing now for several years is the BlueSky Smoke Modeling Framework. So I'm going to go into more detail with the BlueSky system, but then I also want to cover other systems, such as the NOAA air quality system that includes smoke, the HRRR-Smoke, the AIRPACT system here in the Northwest, and then two systems in Canada, Firework and the Canadian version of BlueSky, because we share smoke, quite a bit of smoke, back and forth across the border. And then I want to go into a little bit about a monitoring data tool, and then also talk about satellite data. I think we're seeing sort of a revolution in satellite data that's useful for smoke and fire, and really, I think, at the tip of the iceberg, actually, on the capabilities that are out there in the next several years. And then I want to talk about the Wildland Fire Air Quality Response Program and the Air Resource Advisors that are deployed to incident management teams as part of that program. And then finally, just highlight a couple tools where you can go do your own smoke modeling. So smoke forecasting systems. There are 6 systems listed here on this slide. And so 15, 16 years ago, when I first started working in smoke and working with the BlueSky system, we didn't have any of this. This list did not exist. So there's a lot that's been happening over the last 15 plus years. And so I'm going to go into details of the BlueSky system and then also cover some of these other systems that have since come online. And all of these systems they do some things similarly and they do things differently as well. So I want to highlight some of those similarities and differences and what each system sort of brings to the table, you could say. So the components to calculating fire emissions and then modeling smoke from those fire emissions. And so we sometimes refer to this as our stair-step diagram. This might be familiar to many of you, but it shows the basic components necessary to calculate fire emissions and get those emissions into a dispersion model or a full air quality modeling system. And there's many, the alphabet soup underneath each of these steps are the different models or data sets that can be used for each of these steps. And you can think of each of these steps as actually research areas in their own right. There's a lot of research going on within each of these steps. And so the first thing that you need when you're going to model smoke is you need information about your fire. Where is fire happening on the landscape? And that can actually be a rather difficult question to answer. And so if you're on a forest, if you're conducting your own prescribed burn, you have a pretty good idea of your fire location, your fuels, the size of the fire, that sort of information. But if you're looking at fire from a national standpoint, perhaps trying to put together a national emission inventory, that information can actually be very difficult to get at. So that's fire information. Then there's fuels. You need information about what fuels are available to burn on the landscape. And there's several different data sets and mappings of fuels out there. Within the BlueSky system, we're using the fuel characteristic classification system. And then once you have the fuels, then there's fuel consumption. So how much of those fuels burn in a fire? And so in the BlueSky system, we're using the consume model that researchers here in my lab have been developing for many years, and that calculates the fuel consumed for a particular fire, a particular location. And once you have fuels consumed, you need information about the emissions that are coming off of those fuels. So this is where emission factors come into play. And so an emission factor, when you take your total fuel consumed, so let's say in kilograms, you multiply it by an emission factor so you can get grams of, for example, PM2.5 that are emitted per kilogram of fuel consumed. So that's your emission factor. Then you to get your total emissions, and then finally you need to spread those emissions out in time and vertically in the atmosphere. And so to get a three-dimensional, or actually a four-dimensional emission profile that then can be input into a dispersion model or into an air quality modeling system that has atmospheric chemistry associated with it. And with all of these steps, meteorology also plays a huge part in all of this. And so here this figure is just showing, it's trying to get at the idea that large uncertainties exist within each modeling step. And so you can, we could debate probably how big these uncertainty bars are and variability, or you could also think of them as just natural variability as well. And it depends on your application. Fuels, though, typically are one of the components that consistently have one of the largest variabilities associated with it. You can easily have an order of magnitude difference in your fuel loadings depending on natural heterogeneity of fuels out on your landscape and how those fuels are perhaps mapped. So with all of these pieces, we try to do smoke modeling with that. And with sometimes our smoke models, we get the right answer and we're really happy, and hopefully we're getting the right answer for the right reason. But sometimes there could be compensation going on with these different components, one overcompensating, one perhaps underestimating things. So all of this is a lot of research, areas of research that is continually ongoing, and ideally, eventually, we want to get to the point where we're getting the right answer for the right reason. So with that, that's a little bit of a background on how, conceptually, how smoke modeling systems, the components within a smoke modeling system. And so one smoke modeling system that is available is the BlueSky system. That's the one that I'm most familiar with because that's one I've been working with for many years now. And so over the last several years, we've been really tailoring a lot of our BlueSky smoke forecasts for use when there's large-scale wildfire smoke impacts. So ideally useful to people out with incident management teams and ultimately air quality and health agencies as well. And so we're taking all of those components that I just talked to you about and calculating fire emissions and putting these fire emissions into the HYSPLIT dispersion model. And so HYSPLIT is a model that's developed by NOAA, and it does not have atmospheric chemistry associated with it. It just is it's just primary PM2.5 concentrations. So with the HYSPLIT model, we're able to calculate hourly PM2.5 concentrations from various fires across the landscape. And we do this with a wide variety of domains. That's one thing that HYSPLIT is, one of the big benefits of HYSPLIT is that it allows us to be nimble, and we can easily adapt it to different domains and different resolution domains. And so we're applying, we do, there's a list of probably about 8 or 9 different domains here, and we do probably about 30 to 40 forecast mode, smoke forecast mode runs every day with these different domains. So there's a 2-kilometer resolution domain that covers California and Nevada. There's a larger 6-kilometer domain that covers the western U.S. Then there's the 1.33-kilometer domain over Washington, Idaho, and also recently extended down through Oregon. And then there's the 4-kilometer resolution domain that covers the entire Pacific Northwest. And so we get the California domains from Desert Research Institute. They run the WRF meteorological model. We get the Northwest domains, the 1.33 and 4-kilometer domains from University of Washington running the WRF forecast model. And then from the National Weather Service, we're getting a variety of other domains that cover the continental U.S. at a 12-kilometer and a 3-kilometer resolution, and also Alaska. And then recently we've added a 1.8-kilometer resolution domain from the University of Arizona over Arizona and New Mexico. And then finally there's 1-kilometer high-resolution fire weather domains available from the National Weather Service. And these domains are movable, and they've been super hugely useful to have available to us during Western wildfire season, because if there's an area that's not already covered with some of the high-resolution domains that are static, we can work with the National Weather Service and request moving these domains over particular wildfires of interest. And so in this particular figure, those 2 domains are shown over the Northern California, Southern Oregon area, and then also over the Montana area. And this is for this last summer, 2017, Western wildfire season. So lots going on behind the scenes with these systems. And so, let's see. And then I also wanted to mention fire activity information. So to initialize the system with, we use fire detection, satellite fire detections from the NOAA Hazard Mapping System, the HMS. And then we process those fire detections through a system we call SmartFire 2. And so what SmartFire 2 is, it starts aggregating these different detections together and trying to identify when these detections all perhaps belong to a single fire. And then also it assigns a fire type. So we try to get a little bit smarter about whether it's a wildfire or a prescribed fire, because that actually has implications for how we, especially how we spread emissions out over time. And then also fire size, trying to get an estimate of fire size that can be used in the modeling system. So to access the output, the daily forecasts from running BlueSky in a forecast mode, you can go to tools.airfire.org and click on the BlueSky Daily Run Viewer. And if you do that, you'll get a screen that looks something like this. And so this is a listing of our various runs, and it doesn't have the full list here. It's just a snapshot of the web page. And so you can see we've tried to organize the runs. We have the runs for the Northwest. We have the runs for the West and Southwest. We have runs for Alaska. And if you click on Map, you can go into an interactive Google Map application that you can then animate your smoke. You can animate through and look at smoke plumes moving and changing on an hourly basis. And then you also have, if you clicked on the KMZ file, or excuse me, the KMZ link here, you would download a KMZ file that you can then bring into Google Earth and then create your own maps, pan and zoom, and control the animation that way as well. We try to make the web page smart enough to know when the runs are finished and available or when they're running. So when you see green boxes here, that's always a good sign that the particular forecast run completed successfully. If you see a red box, that means like, uh-oh, something failed and we need to go look into it. And then we also have a status. If the run is still going, you can look at some status logs to try to get an idea of how complete the run is. So for example, if you had clicked on a map, one of the map links if you clicked on the map link for the 2-kilometer California-Nevada domain back in, let's see, this is December 10th, you would get put into what we call our WebSky viewer here. And so this is a Google Map application where you can zoom in and pan around and animate. You have animation controls up top where you can animate through and look at hourly PM 2.5 concentrations. And these are near surface PM 2.5 concentrations. And in this case, this is for the Thomas wildfire that was in Southern California near Santa Barbara back in December of this year. So here we have a snapshot of the satellite fire detections, those locations that went into the model run. If we were to click on one of these little icons, a pop-up box would show up, and then you would have information about the PM 2.5 emissions, the total emissions, the estimated acres that went into the run, that sort of information. And then the red shading is the modeled hourly PM 2.5 concentrations. And then you can select whether you want hourly to look at hourly data, whether you want to look at a 3-hour running average, a daily maximum, or a daily average as well. So that was a very quick overview of some of the output products and capabilities of what we do when we run the BlueSky system in a forecast mode. So that was just the first smoke modeling system in that list of 6 that I started out with. So the second one I want to mention is the AIRPACT system here in the Northwest. And AIRPACT is running at a 4-kilometer resolution over the northwestern U.S., and it's also using the 4-kilometer resolution WRF meteorology from the University of Washington. And so AIRPACT uses CMAQ, CMAQ, Community Multiscale Air Quality Modeling System. And so that's an air quality modeling system that has full atmospheric chemistry on. So it includes emissions from fires, but then it also includes all other anthropogenic sources. So your vehicles, your stationary sources, your biogenic emissions, all of that is included in an AIRPACT run. And it has atmospheric chemistry turned on so that you can also start looking at ozone formation, and you can also look at particulate matter that's formed as a function of chemical and physical processes in the atmosphere as well. And so we work with AIRPACT, and AIRPACT is run at Washington State University, and they're using BlueSky. BlueSky is a component of AIRPACT in that BlueSky is providing the fire emission estimates. So we're really lucky to have this system here in the Northwest, and it's been running for many years and is supported by a consortium of various agencies, air quality agencies, universities, federal cooperators here across the Northwest, and also including Canada. And then the next system I wanted to highlight is the NOAA HRRR-Smoke system. HRRR is High Resolution Rapid Refresh, and this is a system that is running nationally at a 3-kilometer scale, and they're also running it for Alaska. And this system is using the WRF Chem model. And so what is unique about this system is that it's a case where we have a coupled meteorology and smoke model together. So we have a coupled fire atmospheric model here, or I should say smoke atmospheric model here. And so that's very unique. Most air quality systems, dispersion systems are separate from the meteorology, in that the meteorological model will be run first, and then that meteorology then is used to drive an air quality model or a dispersion model. With the HRRR-Smoke, though, there's a coupling that occurs where we know that for example, where the air quality and can actually modify the meteorological wind field. So for example, in the cases where we have heavy smoke in the atmosphere, that smoke can actually cool the atmosphere. So by having a coupled model here, we can start taking that into account in our modeling system. And so this was probably particular interest, especially this last summer, where there was a lot of smoke across the entire Northwest. And even Cliff Mass, on his blog, and Cliff is a professor at University of Washington, and he runs the WRF forecasting system there. And even in his blog this past summer, he was talking about how the meteorological model could be as much as about 10 degrees warmer than what was actually measured at the surface or near the surface. And that was because of the cooling effects of smoke. So the other unique thing about the HRRR-Smoke system is it's using fire radiative power to estimate from the VIR satellite to estimate both plume rise and emissions. And so HRRR-Smoke is run 4 times a day at 0, 6, 12, and 18Z, and they are 36-hour forecasts. And so I just wanted to give a little bit more of a view of the output from the HRRR-Smoke here. The HRRR-Smoke is being run for the Thomas wildfire down in Southern California. And so these are near-surface PM2.5 concentrations. And then here's a look at the vertically integrated PM2.5 concentration. So we're looking at a total sum of PM2.5 through the vertical column of the atmosphere. So not just the surface, but also what is aloft. So this visual can give an idea of longer range transport of smoke, and can also be useful to compare with what satellites might see regarding smoke. Then there's also the National Weather Service. The National Weather Service is running 2 different forecasting systems. They're using the HYSPLIT model, and they're also running CMAC. So they're using HYSPLIT in a similar manner that we've been using HYSPLIT with the BlueSky system, and we're also working with them. They're using BlueSky fire emissions in their calculations as well. And so they run HYSPLIT in the forecast mode, and then they also are starting to pull fire emissions into their full air quality modeling that they do with the CMAC model. And so they run at a 12-kilometer resolution and go out 84 hours in time. And here's a panel of some of the where to get some of the output products that you can go to from the NOAA National Weather Service webpage. And I also wanted to mention with the National Weather Service that they have these high-resolution fire weather domains. And so there's a web page associated with those high-resolution fire weather domains. And what's nice about this website is they offer various meteorological products on this web page. So you can get your near-surface winds, your near-surface temperatures, that sort of information from these domains using this web page. And then we also partner with the National Weather Service to have access to these domains during Western wildfire season, so that we often pull these domains in and set up custom runs for BlueSky. So if there's, for example, an air resource advisor deployed out with an incident management team, and they have specific information about the fire that can be very useful and help improve an air quality or a smoke forecast model run, we'll work with them and these high-resolution domains to set up custom BlueSky runs. And then those custom BlueSky runs are also available off of our BlueSky Daily webpage. And then finally, there's 2 systems operating in Canada. And the first system is known as Firework, and it's being run by Environment and Climate Change Canada, and it uses the GEMMAC air quality modeling system. And they're running GEMMAC at a 10-kilometer resolution, and the forecasts go out 48 hours. And they're using the Canadian Wildfire Information System to estimate Canadian emissions, and we're working with them to incorporate U.S. emissions as we calculate through the BlueSky system as well. And what's nice about the Firework system here is it runs for a North American domain. So for example, with the Fort McMurray wildfires back in 2016, we could watch, this was a very useful system to go to and watch the large-scale smoke transport that was happening from across Canada and down into the lower 48 of the U.S., and even sometimes reaching out to Washington, D.C. And since they're running GEMMAC, it's a full atmospheric chemistry model as well. And here we're looking at PM 2.5 only from the fires up there in Canada. And then there's BlueSky Canada. So Canada has been adapting BlueSky to run with their systems, to run with their CWFIS system to calculate Canadian emissions, and then trying to merge our emissions across the border, U.S. and Canadian emissions together in the domain. And they run at a 4-kilometer and a 12-kilometer resolution and go out 48 hours in time. So that's a quick overview of the 6 various smoke forecasting systems that are out there. And so now I wanted to highlight a smoke monitoring tool that might be useful for you. And so if you go to tools.airfire.org and click on PM 2.5 monitoring, you'll go into our smoke monitoring tool. And what this is it's trying to bring together monitoring data from several different networks. And so not only permanent monitors that air quality agencies at the state level have deployed across their state and that are available in the EPA AirNow system or AirNow Tech system, but also pulling in the information from the temporary monitors that get deployed as part of, that get deployed specifically for wildfires. And so here's an example of, let's see again, this is looking at California in December, so the Thomas wildfire, and the circles are the permanent monitors, so that those are monitors that are out there year-round, and then the triangles are temporary monitors. Those are monitors that were deployed specifically for wildfires. And so this website is designed to give you relatively real-time data. So it keeps a history of up to about 45 days in the past. And so if a monitor has not been reporting data very recently, then it becomes gray shaded out. So here you can get an idea of how many monitors were deployed in the fall in California, specifically for wildfires, and they've probably been pulled at this point and they're no longer being run. So it gives you a look at the temporary and permanent monitors that are out there. And then with just a click of the button, you can click on a circle or a triangle, and you'll get a quick little time series of PM 2.5 concentrations being measured from that monitor. And so in this case, I had clicked on 3 different monitors down in the Santa Barbara area, and these hourly concentrations are color-coded by the air quality index. So you can get an idea of, using the AQI, quick idea of how good or bad your concentrations are at these different locations. And so green is good, yellow is moderate, orange is unhealthy for sensitive groups, red is unhealthy, purple is very unhealthy, and then there's also if you were to see a dark brown there, that would be hazardous. So there were periods during the last, and these little time series are 8 days, they show the past 8 days. And so, for example, over the past 4 days at this point, air quality was in the unhealthy to very unhealthy range at some of these locations. And then also when you click on one of these points, you can also get a time series, if you were to scroll down, a time series of 1 hour of the actual 1 hour concentration. So that's what the gray shaded dots are here. And then in this case, the line is a 3-hour rolling mean. And we're in the process of doing some substantial updates to this monitoring data tool. And so, for example, this running mean would also actually be the EPA Nowcast. So things like that are in the works, and those updates will be ready probably in about another month. So that's surface information. So far I've covered looking at various smoke forecasting systems out there, looking at a monitoring tool that tries to bring together near surface PM 2.5 concentration information. And so now there's satellite information, so looking at things from above. And there's a lot going on with satellite information right now. And so let's see, the GOES-16 satellite, it launched in November of 2016, and this past summer was the first time we had products available from the GOES-16 satellite, and they were quite amazing. So I'm going to show you a couple figures on that stuff. Let's see, the GOES-S just launched. That will become GOES-17, and that just launched about 3 weeks ago. And so GOES-16 is in the GOES East position. GOES-17 will be in the GOES West position, and these are geostationary satellites. So they sit in the same spot at the equator and watch the world from that spot. Then there's also several other satellites. There's been the MODIS that's been around for a while. Then there's VIIRS, and the VIIRS instrument on SIMI NPP, and those are polar orbiting satellites. So they have a higher resolution than the geostationary satellites, but they're also, their data is, there's swath data that's available 1 to 2 times per day. So while the geostationary satellites sit there and watch the same point on Earth and send data back every 5 minutes, for example, now is what we're seeing with GOES-16. The geostationary, the polar orbiting satellites give you a swath of data 1 to 2 times a day. And to augment that, the polar orbiting satellites, the NOAA 20 satellite just launched back here in November. So that swath data comes in about 50-55 minutes ahead of what we see on with the VIIRS satellite data. So all this is just very new in many ways. And so I wanted to mention first NASA WorldView. And NASA WorldView is a great website to go to just get a quick and pretty picture of what's going on across the landscape. And so it brings in MODIS and VIIRS data, and you can also import other data as well. And it's easy to step through in time on a daily basis using the controls at the bottom. And here we're looking at September 6th in 2017. So just this last year, when there was a lot of fire activity across the western U.S. Excuse me. And here we see just smoke blanketing the northwestern U.S. and Canada, BC area. And so we're looking at a visual of the smoke, and then we're also, all the hotspot, all the red points are the satellite fire detections. So we can see where all the fires were currently occurring at that time as well. Then there's GOES-16. So I mentioned GOES-16, and it launched just over a year ago. And this past summer, we started seeing the first products with it. And GOES-16, it was quite phenomenal. We were able, here's an example of visual smoke from September 4th across the northwestern U.S. And data are being returned up to every 5 minutes for the continental U.S. using GOES-16. So in this particular animation, if you were to animate through in time here on the screen, you would see, you can actually watch smoke plumes develop on a 5-minute basis. And it was amazing to watch. And this web page, it's a little clunky. You got to, give it, if you go investigate it, give it a little time for your browser and your system to update. There's a lot of data behind these visuals. So you can look at the visual smoke plume development using GOES-16. You can also look at fire temperature. There's a fire temperature overlay as well. And this is an example of a fire temperature overlay, again, from September 4th. And so all the little red dots that you see across the domain, those are fire temperature being detected by the GOES-16 satellite. And again, this data is coming in every 5 minutes. So in some cases, for the larger wildfires, it was almost like you're almost able to start detecting fire progression with this. And so all this is very new. The provisional products are not quite even ready yet. And so we're hopefully going to be getting, starting to work with this data in the coming months and see what it brings. And then another satellite web page I wanted to mention is the IDEAS and eIDEAS web page. And so this has been a NOAA effort, and eIDEAS stands for Enhanced Infusing Satellite Data for Environmental Applications. And so here's a snapshot of the eIDEAS web page, again for September 4th, 2017. And in this case, so the eIDEAS webpage is displaying the VIIRS aerosol optical thickness here. And so the aerosol optical thickness is a measure of the total column through the atmosphere of aerosol loading, in a sense. It's a measure of how aerosols scatter and absorb light through the total column of the atmosphere. So when there's a lot of smoke, a lot of aerosols in the atmosphere, you're going to get a high aerosol optical thickness. And so there's also, so that's one of the primary products that's being displayed here, and this is from the VIIRS instrument on the SUMI NPP satellite. And there's also, you have over on the right other selections of information you can display at the same time with this satellite data. There's a smoke mass that's calculated. You could turn that on. There's also, they also use an algorithm to take the satellite aerosol optical thickness and try to calculate a near surface PM2.5 concentration from that. You can turn on the PM2.5 concentrations from the AirNow system. So in this case, those are turned on in what you're looking at on the screen here, and that would be the little color-coded dots there, and they would be color-coded. They're color-coded by air quality index. So with the AOT layer turned on and also the surface PM2.5 concentrations turned on, you can start getting an idea perhaps of how much smoke is near the surface versus how much smoke is aloft as well. And then let's see, there's also fire radiative power. You can turn that quantity on, and that's the sort of red blobs that you might see in, let's see, like for example, across the Cascades and from Northern California up north. There's fire radiative power. And so you can start looking and playing with these different pieces of information and getting an idea of smoke transport across on a regional and continental basis with this tool. And so finally, I just wanted to wrap up a little bit. We've been looking at several pieces of data from September 4th, 2017. So we just saw some of the satellite information from GOES-16 and from the eIDEAS webpage. And this is going back to the monitoring data tool, where it's showing a map of the temporary and permanent monitors across the U.S. and also up into Canada. And again, the color coding is by air quality index, so you can get an idea for September 4th how smoky and how poor the air quality was across the much of the western and northwestern U.S. during this time period. And if you were to animate over into September 5th and 6th, you'd actually see the poor air quality creep over into Seattle, Seattle and the Portland area, which was rather unusual typically, but there's a strong, in this case, there was a strong, during this time period, there was a strong easterly push of wind blowing the smoke towards the west, and so those areas got impacted by smoke as well. And then here's just an example of some of our output from the BlueSky smoke forecast for this particular day. And in this case, we were using the GFS, the Global Forecast System Meteorology, and doing a total column average of PM2.5 concentrations to get an idea of something to compare with the satellite data with what we were seeing, for example, with the VIIRS aerosol optical thickness. lots of smoke. So with all of this, we often talk about putting on your smoke glasses because there's lots of pieces of information here. There's your surface PM2.5 concentrations, there's your smoke forecasting models that are trying to give a look into the future of what the smoke could be doing. There's the information that you get from the satellite data. And so pulling this all information together is not easy, and it takes interpretation. And so we call it putting on our smoke glasses. And I just wanted to highlight quickly, like one quick example, starting to pull some of this information together into a cohesive package. There was the Carlton complex wildfire in Washington State in 2014, and the Carlton complex burned over 250,000 acres. And here's a look at the burn scar from the Carlton complex. And so the Carlton complex occurred near two small towns of Winthrop and Twist in the Methow Valley. And there was an air resource advisor deployed with the fire, and I'll cover that in just a little bit as well. And the person was doing forecasts, air quality smoke forecasts for the Winthrop and Twist area, and was examining in this case, we're looking at the measured PM2.5 concentrations from two monitors that were put out in Winthrop and Twist. And so the blue shows the 1 hour PM2.5 concentrations. The red squares show the 24-hour average PM2.5 concentrations. And then the red bar going across is the National Ambient Air Quality Standard of 35 micrograms per meter cubed. So ideally, you want to keep your 24-hour average PM2.5 concentrations below that bar, the National Ambient Air Quality Standard bar. And these two towns are actually very close together. They're about 12 kilometers away from each other, 9 miles. And smoke actually, this is complex terrain. And so small mountain valleys. And so smoke behavior was different between these two towns. And so in certain time periods, the 1 hour concentrations might be higher in Winthrop, and then other times they might actually be higher in Twist as the plume waved between these towns, essentially. And so that's what we're looking at here. Here is the red is near surface PM2.5 concentrations that were forecasted from the BlueSky system using the 1.33 kilometer resolution meteorology from UW. And if I were to animate the plume underneath between these two towns of Winthrop and Twist, which are denoted by the little blue triangles, you could see the plume wave back and forth between these two towns. And then what I've done is I've overlaid a square here. And this square represents a 12-kilometer resolution, 12-kilometer box, 12 kilometer on each side. And if you split that 12-kilometer on each side box up into 9 by 9, 1.33 kilometer grid cells, you can get an idea of how meteorological grid resolution really impacts the smoke modeling that you do. And so in this case, we're looking at the 1.33 kilometer domain output. And then if we were to go to the 12-kilometer resolution domain output, smoke concentrations would look something like this. So in this case, for the higher resolution domain, we tend to look at that more to get an idea of how to resolve complex valley flows. And then the coarser resolution results are often used to look at longer range transport. So with that, putting on our smoke glasses, there's all the complexity of the data and information that are available now during periods of wildfire smoke impacts. There's the air quality, the Wildland Fire Air Quality Response Program. And so this program's been growing over the last several years. And it started back with the Wildfire down in Arizona and New Mexico when there was large-scale smoke impacts across that entire region. And then every year it's been growing. And so as part of this program, air resource advisors are deployed to incident management teams or to geographic area commands. And they provide a consistency in modeling, monitoring, and messaging. So they are looking at the monitoring data, they're looking at the modeling data, and they're creating daily smoke forecasts, daily smoke outlooks of what to expect from a fire. And by being deployed with the fire, with the incident management team, they have access to the more detailed information about the fire that can be critical when trying to do smoke forecasting. For example, are there burnout operations planned? You know, what is being expected as far as fire behavior for the next day? Things like that can be critical to trying to get a good smoke forecast out there. And then they also deploy temporary monitors, so many of those triangles that you'd see on that smoke modeling or smoke monitoring tool. Air resource advisors are the ones that are out there deploying many of those monitors. And so they deploy, there's a central smoke monitoring cache, and there's about 20 e-samplers, 6 e-BAMs, and we're also, there's experimentation going on with trying to get other different sensors to use as well. And so we've been conducting training every year since 2013. We're getting ready for our next Air Resource Advisor training coming up in just about a month now. And Pete Lom is the coordinator and has helped really, I mean, he's been leading the development of this program. And here's just a look at some of our Air Resource Advisors, someone doing a briefing, a public briefing, another couple of Air Resource Advisors briefing the incident management team, another Air Resource Advisor putting up a smoke monitor, and then the bar chart is showing the number of deployments per year over the last several years. So actually this last year, I think we actually topped over 100 Air Resource Advisor deployments. And one of the things that an Air Resource does is creates a daily smoke outlook. So they do a forecast of what to expect as far as smoke concentrations into the future, so for tomorrow and for the next day. And here's an example of what one of those smoke outlooks looks like. And there's a couple different components to this outlook. There's a map showing where the fire is located and then where different monitors are located. So PM 2.5 monitors, both permanent and temporary. And then the Air Resource Advisor will put together the outlook. They'll talk about what's expected as far as smoke, what's expected as far as fire behavior, and how that can impact smoke and other pieces of interest. And these outlooks are disseminated widely. There's daily conference calls between various agencies, various air quality agencies, health agencies, land management agencies, everyone interested in what's going on with smoke and the fire. Many people will be on these calls, and so these smoke outlooks get disseminated to people that would be on these calls, to different email lists. The public information officers will use them, and they get posted through the PIO trap lines. They also get posted on smoke blogs, and smoke blogs are becoming a very popular way of getting information, especially for the public, to get information about what could be going on with smoke, because people want to know what can they expect today, what can they expect tomorrow as far as smoke. When can my kids go out and play? When can I go to the grocery store? And this is especially critical for people that already have health issues such as asthma, or children, or the elderly. And so smoke blogs are becoming very popular to go to and get information from. And for example, the Washington State Smoke blog had over 140,000 hits on, September 4th this past year. So a lot of hits, and they've been getting used more and more. And here's some of the links to some of the smoke blogs here in Washington, Oregon, California, Idaho. So I've cruised through several different topics here, and a lot of information that's readily available on the web, and a lot of its focus has been focused on wildfire and wildfire smoke impacts. But I also wanted to let you know that you can also do your own smoke modeling. so, for example, if you have your own prescribed fire, you can go to our BlueSky playground and do your own smoke modeling. And so I've put, let's see, if you go to tools.airfire.org and click on BlueSky Playground, you'll go into the BlueSky Playground application, and here's just an example of what it looks like. And you can put in information about where your fire is located, and then there's tabs across the top here where you can have control over the fuels information, your fuel moisture information, some of the consumption data, all of that, all of the pieces that go into calculating fire emissions for your particular fire. And then you can put that into your own HYSPLIT smoke dispersion run and get your own prediction, estimation of 1 hour PM 2.5 concentrations from your particular fire. And then I also wanted to mention HYSPLIT trajectories. HYSPLIT can also be run in a trajectory mode. And trajectories just give you information about where a parcel of air will travel in a wind field. And so it does not have any information about emissions or PM 2.5 concentration. It's just purely showing where a parcel of air can travel in the atmosphere. But they're really quick and easy to run, and they give you some really neat information, especially about how an air parcel can travel vertically in the atmosphere. And so, for example, in this particular simulation we're looking at, I released a trajectory at 50 meters, 500 meters, and 2,000 meters above the ground. And then those parcel of air, that trajectory, each of those trajectories go into a three-dimensional wind field. And we're looking at a track of how that parcel of air traveled in that three-dimensional wind field, depending on where it was initially released. And as you can see, these different trajectories can take quite different pathways, both horizontally and vertically in the atmosphere. So I just wanted to point this out to you as well. And then with that, I will stop there. And if anyone has any questions, I'd be happy to take some questions. And I also just want to say thank you to the many people and agencies that help make this all possible. And I'll stop there and send it back to you, Carrie.
Okay, great. Thank you, Susan. That was fantastic. There's so much information out there on smoke, tools, data, all of that. It's pretty incredible. And so thank you for that overview and all that information. We did have a couple of questions come in, and while I'm reading these questions, go ahead and think of your own and send them to me using the chat window or the question and answer window. So our first question is, what about data from Mexico, Susan? Is there data? Is it not relevant to what we're doing here in the States and Canada? Yeah,
Mexico. Yes, it's relevant. Definitely. We currently don't have data from Mexico. It would be great to get data from Mexico. I don't actually even know what might be available from Mexico. There's other researchers in my lab here that have gone down and done some work and field work down in Mexico and in down in South America. But yeah, we haven't yet ventured into trying to estimate emissions from Mexico yet, but that's definitely a place to go, a thing to do.
Right. Susan, also there's a question, they've heard that mercury is spread through wildfire smoke. Is that true? And do you track that at all?
Mercury can be emitted from wildfire smoke. We're not specifically tracking mercury. Mercury is difficult because much of the mercury is a function of what was previously deposited. So there needs to have been like a mercury source that deposited mercury into the vegetation, and then the fire just re-releases that mercury. So yeah, mercury is difficult.
Mm-hmm. Susan, is there any training on that BlueSky playground?
We do training as part of RX 410, and then actually I just recently did a brief webinar, about a 20-minute video on running BlueSky Playground and on running a HYSPLIT trajectory. So I can send you that link.
Right, and speaking of links, Susan, I've had a couple of folks ask that there's so much great information in your presentation. Is the presentation available to the attendees, or is there a site where we can go to where all of these links are listed? I know from listening to your webinar today that I'm going to update the consortium website where we do have some of these tools listed. But what do you recommend to folks for connecting with all these tools?
Yeah, okay. I do have like just it's a 1+, excuse me. Oh, excuse me. It's a 1+ page of links. So I think it has all of the links that were in my presentation here, so I could share that.
Fantastic.
There's also, well, this will be recorded. I've done something similar a couple months ago, which recorded, so there's that recording as well. And I can, I'm happy to make this presentation available too.
Okay, great. Yeah, so that is a good point. I will archive this webinar on the Northwest Fire Science Consortium website. Also, Susan, you can send me that list of links, and I know who all attended today, and I'll send that out to everybody. We have another question here. I'm interested in smoke resources that are available to the public, especially those who are most susceptible. Oh, that was a hard word to get out. Is there a list of websites the public can access, or are the blogs their best bet?
I would recommend starting with the blogs.
Okay.
Yeah.
Is there a way to expand the domains in the central and eastern U.S.? What is the process for setting up the data for these regions, such as who are the agencies that would need to be involved?
It varies. Let's see. Right now, we're pulling in a 3-kilometer resolution NAM from the National Weather Service, and that's over the continental U.S. So that's actually that's a great resolution to have, period, in general. So I'd recommend that first on a national scale. It only goes out, I think it's a 48-hour forecast, so it'd be nice if it went out longer, but that's what it is right now. That's with the BlueSky forecasting webpage. We're also working on a new version of BlueSky Playground that will have that 3-kilometer NAM in it as well, so that if you're doing your own playground run, you can use that higher resolution meteorology too for the east. Otherwise, I guess as far as like these different, the 1.8-kilometer Arizona, New Mexico, the 2-kilometer California, Nevada, the 1.33-kilometer Northwest, those high-resolution domains kind of are a grassroots effort in many ways. Different universities are meeting needs of users in the region. So like the Forest Service is helping support the University of Arizona with that 1.8-kilometer domain. We help support the University of Washington and their WRF forecasting system. And kind of similarly over California, Nevada, Desert Research Institute runs that, and they get support from different agencies that are just interested in seeing that higher resolution meteorology.
Mm-hmm. Susan, is there a low-end acreage/fuel load where the accuracy of the models markedly decreases?
Mm-hmm. I haven't, excuse me, I have not come across like any sort of threshold like that. More, it's really a function of how well you're estimating your emissions and then how well your meteorology is doing with dispersing those emissions. And so I don't think it's necessarily a certain threshold really that comes into play as far as an emission value.
Okay. So I think that's all the time we have for questions. Let me say again that I will post this archived webinar to the consortium website, which was listed at the beginning as nwfirescience.org. Also, if you check out our tools in the pull-down menu, I'll upload a lot of these tools so that you have access. And Susan will send me a list of the links, which I'll send out to all of the attendees today. And yes, the presentation will include, oh, actually, I'm sorry, it does not include Susan's transcript. It's just her voice. So with that, I just want to say thank you so much, Susan, for providing all this wonderful information. There's a lot of information out there. Thank you so much for talking with us today. And I also want to thank you all for taking time out of your busy schedules to listen in with us today. We always appreciate you tuning in. We also like to hear from you. So if you have a question or a suggestion, don't hesitate to get a hold of us. So thanks again, everyone, and have a great day.
Thank you.
Thank you.